myself, I'm Guru Prasad Sridharan. I work as a software architect at PhonePe, in the data platform team.
Yeah, hi. I am Nitish Goyal. I work as a software architect for infra services and ads platform.
Okay, with that, we'll take a brief look at the agenda. So we'll just maybe give a quick overview about what PhonePe does and what has been our journey like and why we use Kafka, right? The various use cases for which we use Kafka at PhonePe, and we give a little bit brief about what disaster recovery means for Kafka and why is it needed. Then talk about the various different ways of implementing disaster recovery. Then we'll look at one specific implementation, right, which is relying upon MirrorMaker, and we'll talk about how PhonePe, started using MirrorMaker and how we are using it in prod. Okay, so about PhonePe, we are a fintech company, which was founded in 2015, and our mission is to democratize digital payments by providing a safe, convenient, and secure solution which is accepted all over India. So to that end, we have launched. We offer several different services. Some of which you find below here. So we support different kind of payment instruments like UPI, wallet, and card payments. So we have solutions for offline and online merchant payments, and we offer other value-added financial services such as insurance, mutual funds, stockbroking, and lending services. Of late, we have also gotten into non-financial services like PinCode, which is a shopping app based on ONDC. Then Indes OS, which is an app store. Okay, so this is basically a transaction heat map, which represents the volume of transactions performed in different geo-hashes across India. So just to show you the adoption of PhonePe within India. So this covers the last 3-month period. So we are present, our solution is used in more than 20,000 Indian cities and towns. Now, this is about our journey. So ever since 2015, we have grown leaps and bounds, thanks to the adoption of UPI, demonetization, several other factors, right? So here we are now, right? We have now about 300 million, daily transactions. We are doing 300 million daily transactions on the app with more than 600 million registered users and close to 270 million, monthly active users. So how does this translate to Kafka scale numbers? You can see on the right-hand side, we have close to 50 plus clusters, and we have, these clusters are spanning across different regions, different DCs, and we have 1,000 plus brokers, 500 or more services or apps using them. All this comes down to 60 million plus messages per second transferred. So this gives you a rough idea of what our scale is. So why do we use Kafka, right? So there are a lot of different use cases for which we use Kafka because Kafka is ubiquitous everywhere, it's used everywhere, and finds applications in a lot of streaming and batch processing, pipelines, and change data capture is another category. So where you have to copy data from different databases to achieve disaster recovery for different OLTP databases and OLAP databases as well. Telemetry collection, which is a popular use case. You have to collect metrics, logs, and traces from microservices, process them, and then index them into the TSDB. Then there are a lot of information routing use cases as well, for doing asynchronous processing and giving callbacks and then doing notification delivery. Disasters, huh? So, has anybody ever been in a war room kind of a situation? So this is typically what happens. But if you don't want it to happen, you need to arm yourself with the necessary knowledge, which will help you stay calm during these kind of situations. Just threw in a slide from Dr. Strangelove. Yeah, so what can possibly go wrong here, right? So in short, many things, okay, but here we are going to cover certain, class of failures. So of course, there are node level failures which can happen, but those don't generally result in a disaster, right? So what is a disaster and how can it happen? So for that, you need to understand the kind of failures that can lead to cluster level downtime, right? So it can either affect the availability of the cluster for taking reads and writes or loss of data. So availability loss could happen due to planned or unplanned activity. So loss of uptime again can happen due to like various different reasons. You lose like n brokers if you are unfortunate, right? Where n is like replication factor, and you can also have like you could lose more than like min in sync replicas, or some like cluster split could happen, or like there can be a network connectivity loss between the application and Kafka. So loss of data can happen due to loss of like n number of disks. Now these are the various different failure modes I can think of, some of which or like many of which we have encountered in prod, some of which we are yet to encounter. So doomsday clock is ticking, right, for whomsoever is interested. So this is why we need disaster recovery solution. Not going to go into details of all of them. Yeah, so then you have acts of God, right? So which can lead to like cluster level downtime, like flood, earthquake, fire, and lightning. Now, what is the cost of a disaster and why you should care, right? So disaster affects like uptime of your cluster and like can cause loss of data. So what does that mean, right? Your application can be quite critical, to the working of your product, right? So it can be tied to your, like product's revenue, right? Also depends upon the criticality of the app and the traffic volume that it processes. So Kafka is ubiquitous, like I said, so flexible. It finds like applications in anything under the sun, right? So that you can think of. So one other aspect that I want to call out is like sometimes when critical Kafka clusters go down, right? It can impact like even unconnected flows, because we also use it for telemetry solutions, which will make us like go blind. So this can result in loss of millions of dollars. Okay, so like, I know everybody wants a straight answer, right? So we will get to it. So which applications need it? Why do we need to do DR? Do we need to do DR for every application? I would say no. So you'll have to look at the rule of thumb here, which is, if the cost of the outage is lesser than the cost of like, setting up disaster recovery, then probably it's not worth it. So cost of outage also includes a lot of other hidden components like loss of, like potential customers, and then like how does the, public perceive your like app, right? Could result in really bad ratings, right? Or people throwing their phone, right? Or like, uninstalling your app. Or it could also be necessitated because you're operating in a highly regulated domain, like ours, like a fintech domain. So you have to do it. So in which case it is non-negotiable. So some of the examples of apps which would need it are down below: accounting systems, fraud detection, etc.
Yes.
Go to my colleague.
Yeah. So I'll talk about what are the different discovery patterns you have, and then I'll talk about what are the different ways in which you can set up the replication. So these are some of the key considerations which you should consider while setting up the replication, like what is the criticality of the cluster, what is the cost of implementation. So these are the various considerations which you should consider whether a particular Kafka cluster classifies for a replication or not. There are obvious two ways in which you can set up the replication. One is synchronous replication and another is asynchronous replication. I'll go more details about it in the future slides. So this is asynchronous XDR, and on the right hand side is a synchronous XDR. So in case of asynchronous replication, your one Kafka cluster resides in one data center, and then the MirrorMaker takes care of replicating the logs asynchronously from data center 1 to the Kafka cluster, which is in data center 2. So here everything is happening asynchronous, and MirrorMaker is responsible for replicating across the Kafka clusters. So that is your asynchronous XDR. In case of synchronous replication, your Kafka cluster is split across two different data centers. So few of the brokers will be in data center 1, and few of the brokers will be in data center 2. It's synchronous replication because a client will only get an act once the data has been successfully replicated across both the data centers. So that's on the right hand side is the synchronous XDR. Next, I'll talk about pros and cons of synchronous and asynchronous. So synchronous gives you stronger consistency guarantees because a client is getting an act only once it is replicated across both the data centers. So it is strongly consistent. Consumers can instantaneously switch from data center 1 to data center 2. No offset translation is needed. So if your data center 1 is down, consumers can instantaneously shift to the data center 2 because all of the offsets, etc., has already been copied to the other data center in synchronous fashion. It's cheaper in terms of storage. So let's say if you are having the replication factor of 3, you are only maintaining 3 copies of the data across your both data centers. So in terms of storage, it is cheaper. Cons, it has higher write latencies and lower write throughput. So your P99, which usually if your Kafka cluster is in a single data center, your P99 would be somewhere close to 1 milliseconds or 2 milliseconds. But in case of synchronous replication, it can go beyond 10 ms easily, depending upon the distance between your Kafka clusters or distance between your data centers. Rebalancing takes more time because now the data needs to transfer across the network, across the distance. So rebalancing will take more time. For practical use cases, synchronous replication only works when your data centers are nearby. Like for practical, if they are more than 100 kilometers apart, your synchronous replication won't be helpful for you. So you should use synchronous replication when your production rate is low, when you are like producing very low message count, then you can consider using synchronous replication. Or when you don't care a lot about latencies, like if your application is okay, your P99 going to 10 milliseconds, 20 milliseconds, then maybe you can consider using synchronous replication. Your application writes its own reads, basically where you need stronger level of consistency. Then again, there you need synchronous replication. Primary and secondary DC needs to be at least like only if they are within 100 kilometers, then it makes sense to use synchronous replication. Otherwise, if they are very far or in different zones, you will see much, much higher latencies. Asynchronous replication, your two Kafka regions or two Kafka data centers can be in different seismic zones and or maybe across different continents. So you don't care about the distance between the data centers because the replication is happening in asynchronous fashion. Your latency are not impacted because all of the writes are happening local to your data center. So if your application is running in data center 1, your writes are also happening in data center 1. So your latency is not impacted and write throughput is not impacted. Cons, obvious, one of the cons is it's eventually consistent. So the data will replicate it to the destination in an asynchronous fashion. So it's eventually consistent. Consumer switch is not instantaneous. So if your consumers need to shift from data center 1 to data center 2, the offset translation needs to happen. Although MirrorMaker takes care of that, but still there is some steps which are needed for consumers to understand how to basically do a data like migration when they are shifting from data center 1 to data center 2. Cost of storage is high. Let's say if you are keeping 3 replicas, so 3 replicas in data center 1 and 3 replicas in data center 2, so you are potentially having 6 copies of the same data. So cost of replication is high in case of asynchronous replication. Yes, next to Guru.
Yeah, so now I've talk about like MirrorMaker, right, and how we achieve like asynchronous replication using MirrorMaker. So for those of you who don't know what MirrorMaker is, it's a tool that comes as part of like Kafka, like OSS version itself. So it's basically a Kafka Connect application. I'll not be able to cover like deeply what Kafka Connect is, but I will just like have a brief, I will give a brief explanation about it. So in short, it replicates Kafka topics from one or more like clusters, source clusters to one or more like target clusters. So that is the work done by MirrorMaker. So MirrorMaker uses like multiple Kafka topics to store its own state, so that it becomes the replication, cross-cluster replication becomes stateful. It provides a fault-tolerant, robust, and scalable mechanism for achieving like cross-cluster replication. So you can deploy MirrorMaker in different modes. So you could actually like run it, run it alongside a Kafka cluster. Kafka Connect cluster, which is embedded, which is the most popular mode. If you don't know what Kafka Connect is, or you don't like have an existing Kafka Connect cluster in production, so or you can like have an external Kafka Connect cluster running, which you can like use for like running MirrorMaker. That's the third one. And the standalone mode is mostly for testing, not recommended for production use. Now, yeah, this is a diagram like which just shows how, roughly like 10,000 foot view of like how MirrorMaker works. So to achieve active-active asynchronous replication, so you could deploy MirrorMaker in both the DCs, the source cluster and the target cluster, DC1 and DC2 respectively. So there are 2 topics, T1 and T2, and MirrorMaker running in DC1 actually like replicates the same topics, but when it goes to the target cluster, it is prefixed with the DC ID. So this is to distinguish between like, to achieve like name spacing, so because the same kind of topics can be there, like in the same similarly named topics can be there in the other cluster. So likewise, you can have an inverse of this to like achieve active-active setup. What do we mean by active-active? So cluster, both the data centers can take like reads and writes, and it should get like replicated across both the clusters. So these are the major design goals for MirrorMaker. So first important goal is to like provide a reliable mechanism for replicating topics, right? So this means like checkpoints and state needs to be maintained. So and it needs to be obviously resilient, with respect to like crashes, right? And then provide recovery features and all that. So it's not only about like replicating data. So you need to like replicate DDLs, topic configurations, and ACLs as well, because both of these clusters are in active use, and like newer topics may get created or topic configurations may get changed. It also needs to provide flexibility to transform messages. Sometimes you may have use cases like wherein like you don't want to copy all the messages from a source topic, or you want to like, let's say, make some trivial transformations. Like for example, if it contains source cluster contains JSON messages, you want to extract some part of it, or maybe like even like obscure it or like encrypt it. So those kind of features are should be supported. And obviously messages need to be like copied efficiently. So performance is very essential, because otherwise the consumers will be stale. And like it needs to publish metrics for monitoring the like state of synchronization. So we'll dive deep into the internals. So why Kafka Connect is used? So it's because like Kafka Connect is a framework. You can think of it as a like a stateful stream processing framework, which will just provide the following functionalities. It provides it has good work distribution properties. So whenever you scale up or scale down like workers, so you want the tasks to get like rebalanced across the cluster, so that the replication pipeline itself becomes like horizontally scalable. So automatic retries for failed tasks, and then like stateful streaming computations, monitoring of the like work done, right? So that you can always recover from a like known point, and dynamic task configuration at runtime. So Kafka Connect does all of this on top of like Kafka itself, right? It uses Kafka's consumer group protocol for doing like group discovery, leader election, and work balancing. So we'll see how it does that. Okay, so when you are describing a Kafka Connect cluster, you'll have to talk about like nodes, workers, connectors, and tasks. Nodes are like your VMs and VMs where you run the workers. Workers are like processes, right? So which encompass like connectors and tasks. So a connector is nothing but it's a grouping of tasks, which do one specific thing only. So with respect to MirrorMaker, you can talk about three different kinds of connectors. One is the source connector, which is responsible for like copying the data from like topic partitions in source cluster to target cluster. There is a heartbeat connector, which is supposed to like send heartbeats for like like monitoring the uptime of the Kafka Connect or like MirrorMaker cluster itself. And there is something called a checkpoint connector, which is what sort of aids the offset translation, because the offsets are not preserved when the messages are copied from the source cluster to the target cluster. So this requires some kind of mapping to be maintained, so that the consumer groups, when they shift from DC1 to DC2, they know exactly where to start consuming from. These are the internal topics like checkpoints, offset sinks, offsets, configs, and status. So last three, offsets, configs, and status, these are like typically used by every like Kafka Connect application to store its own config and current status and all that. And heartbeats topic is something that we have already discussed. So this is a high-level overview of like how like a little bit deeper like overview of how the internal like connectors like work in MirrorMaker. So you can deploy in distributed mode, and you can see the internal topics and the replicated topics here. So I have a more detailed diagram which I will go into. So MirrorMaker can be deployed to support different replication topologies, and it can be it can be deployed using different ways of like consuming and producing. So in terms of the replication topology support, you can do all of the ones listed here. So you can do an active passive setup where you only like you have a primary DC and secondary DC, and primary DC takes both reads and writes, whereas secondary DC only does reads. You can do active, right? So which means like bidirectional flow of like information. Then you can do a chain or like a loop, right? Or you can do fan out or fan in. So we will see like where these use cases are, why these use cases are important. So in terms of the deployment topology, there are various different modes of doing this. So one is like local consume, remote produce, and then the converse of it, which is remote consume, local produce. And then you can do local consume, local produce as well. Or you can have a stretch cluster, MirrorMaker cluster, which is spanning across both the DCs. So we'll briefly talk about the active-active setup. So in this case, A and B are like clusters, like which could be running in the, like maybe the same region, right? So basically deployed on different DCs or availability zones, or like they could be running in different geographic regions. So if A is unavailable, we want both the producers and consumers to switch to B seamlessly and vice versa. So this failover procedure typically requires offset translation for consumer groups. So whenever they do the switch, without offset translation, we run the risk of consuming from like outdated offsets. So depending upon the type of consumer, like it may or may not be a problem. So you may have like idempotent consumers or non-idempotent consumers. So for non-idempotent consumers, data duplication is a big issue. So which means it needs to be handled in the batch or stream job. It's not natively, deduplication is not natively supported in MirrorMaker. Okay, so this is an example of an active-active setup where the MirrorMaker itself is running in DC2, right? So that is cluster B. So and it's doing remote consume and local produce, which is the recommended configuration. And you can see, right, like so the same topic is getting replicated, and it is getting prefixed with the correct, cluster alias. So and then obviously the reverse also happens because it's an active-active setup. Now if cluster A goes down, and obviously the consumers and producers, they need to shift, right? So how and how it happens is something like we will discuss about. So now I want to discuss one specific thing, which is the offset translation part. So you may wonder how this is actually achieved in MirrorMaker. So MirrorMaker maintains two different topics for this purpose. One is the offset syncs topic in the source cluster, right? So which is populated by the source connector, which copies data from source cluster to target cluster. So for every topic partition, it maintains the mapping between the offset in the source cluster and the target cluster. Now every Kafka cluster has an internal, topic called consumer offsets, where the consumer group offsets are stored. Now it's the responsibility of the checkpoint connector or tasks to sort of consume, messages from both these internal like offsets topic and offset syncs topic, and then create a mapping which will be like stored in the checkpoints internal topic in the target cluster. So whenever there is a switch happening from cluster A to cluster B, so the consumer group offsets are recorded in the checkpoints internal topic. But of course, it is done only periodically, and it is not like gonna do this for like every every time like batch of messages copied. So of course, like there's a possibility that it may be stale. Failovers, right? We'll talk about failovers. We have already like discussed some aspects of it. So here I'm going to talk about mostly, the consumer switch. Producer switch is actually trivial. So consumer switch, as we have discussed, it requires offset translation. So after Kafka version 2.7.0, automatic offset sync can be enabled. It's an opt-in. So what this does is it basically copies the offsets in the checkpoints internal topic in the target cluster into the consumer offsets topic, so that it can happen seamlessly and there is no external processing required on the part of the consumers. So this will be as close to like the seamless transition that is desired. But there are a lot of gotchas, so we'll probably like discuss this afterwards. So there are even though it's a great tool, like there are some things which are missing. For example, whenever you are like having, let's say, large number of MirrorMaker clusters like PhonePe does, you have like 30 odd like MirrorMaker clusters or more. So it is very difficult for us to understand, right, which producer or consumer is consuming from which region or cluster, right? How to actually like move them seamlessly from one DC to another, right? There's no single control plane for actually doing this. So the control plane is not only useful for disaster recovery scenarios, it's also useful for like doing load balancing, where you can put different clusters, right, in primary and secondary region to good use. You don't need to over provision them, so you can use them for processing purpose as well, and sort of like move them closer to the applications. So we deploy applications across multiple geographic regions, and as close as possible to the customer. So reduced visibility is one thing. Another one is lack of transparent failover. So you will have to like either like go over an L7 application proxy, right, which is actually slow because it adds like overhead, right, every time when you like do message production or consumption, or you will have to like have some kind of automation script like to sort of like switch between the primary region and second region. And then producer and consumer failures also need to happen in tandem, right? So I think like we'll have to like do some kind of coordination in order to like move them. So we'll talk about other known caveats, some of which are known. So MirrorMaker introduces additional overhead in terms of CPU cycles consumption and heap memory. So Pinterest had a KIP like 712 for supporting shallow mirroring as they call it. So even though like in the case of MirrorMaker, we are simply copying data from source cluster to target cluster, it is like going to do all of these operations, right, which would obviously consume like more CPU cycles and heap memory, and it also like leads to poor GC behavior. Connector reconfiguration, again, like it's not always like going to be like dynamic, right? So it sometimes requires like restart of connectors, and like auto scaling is something that we will have to implement on top of like MirrorMaker. So it's not something that is like readily available.
Okay, yeah. Now I'll talk about the one of the clusters which we have at PhonePe and the MirrorMaker setup of that. So we have two regions, one is in Mumbai and another is in Bangalore. So we have a 30-node Kafka cluster in Mumbai region and 30-node Kafka cluster in Bangalore region. And those are getting replicated using a 6-node MirrorMaker cluster. So 3 MirrorMaker nodes are in Mumbai and 3 MirrorMaker nodes are in Bangalore. So it's a shared cluster for isolation and for active-active setup. So that's a typical one of the examples of how MirrorMaker cluster is set up in PhonePe. We have more than 30 plus MirrorMaker cluster setups. As we presented in the first slide, we have total 50 plus Kafka clusters. So those are getting replicated using 30 plus MirrorMaker setups which we have across PhonePe. So this is just one of the examples. This is the standard SKUs for the previous cluster which I showed. Each of the Kafka cluster runs on a 40 core RAID Z1 configured where 5 NVMEs are there and 5 disks per pool. Each Kafka broker has a 256 GB DDR4 memory, and these are the various Kafka versions which are used at PhonePe. And this is a typical MirrorMaker node configuration we have. It runs on a bare metal, so it has 80 cores per node, 560 GB RAM, and it's a 6-node cluster, so number of workers is set to 6. It's replicating close to 1,000 partitions. So there are 500 partitions in DC1 and 500 partitions in DC2. So since it's a bidirectional replication, so this MirrorMaker cluster is replicating close to 1,000 partitions. So the number of tasks is set to 1,000. This is a standard MirrorMaker production configuration. So you can go through it later. We'll upload our slides into Kafka website. So these are the various configurations which we have tuned over time for better production stability. Now I'll move on to the topic replication strategies. So there are two ways in which you can replicate your topics from cluster 1 to cluster 2. So the first strategy is where the topic T1 gets replicated to cluster like DC2 with a DC prefix. So T1 is replicated as DC1.T1. So this is useful for consumers who are only interested in the data which is getting produced local. So in that case, they do not have to consume from the remote topic. They can only continue to always consume from topic T1. So this helps in those kind of use cases. And the second way of replication is where T1 data is bidirectionally getting replicated across the same topic. So this is useful for consumers who are interested in aggregation use cases or for consumers who want to consume from both local topic and remote topic. Because for those consumers now they don't have to run up multiple consumer groups to consume from multiple topics. They can just have a single pipeline which consumes from T1 topic and it is able to consume the data of both DC1 and DC2. So that's the second strategy of topic replication. Monitoring and alerting. So we have telegraph agents deployed on each of the MirrorMaker nodes. So those telegraph agents push metrics to our telemetry platform, which is OpenTSDB. And on top of that, we have Grafana dashboards. Anomaly detection alerts are configured on top of few of the key metrics, which are highlighted here. Record age MS, record rate, replication latency MS. So alerts are set up on these key metrics. This is a snapshot of one of the MirrorMaker Grafana dashboards. Here you can see our BAU replication, asynchronous replication, somewhat like from few hundred milliseconds to 4 seconds. So these are the different topics which are getting replicated via MirrorMaker cluster. And this is the plot of a replication lag across the clusters. This is the view of what load or one of the Kafka MirrorMaker clusters is handling. So it's replicating close to 6.5 million messages per second, which translates to close to 700 megabytes of data per second. Few other metrics are there. Now, what are the other different use cases for MirrorMaker replication? One of the key use cases for what we use MirrorMaker in PhonePe is DB replication. We have Elasticsearch. A lot of applications in PhonePe use Elasticsearch. So for replicating Elasticsearch across data centers, we use MirrorMaker as the key data platform. So translogs are getting copied from ES to Kafka, which gets replicated to another Kafka via MirrorMaker in the destination cluster. And then those translogs are getting ingested into the destination ES cluster. Similarly, POC for replicating HBase is work in progress using Kafka. So that's work in progress. Various other use cases are data isolation. Like in one of our events platform, the data comes to the primary Kafka cluster. And then from primary Kafka cluster, the data flows into different Kafka clusters as per their needs. So there we use it for data isolation purposes. So different teams gets the data based on their use cases from our primary events platform Kafka cluster. Various other use cases are like data reorganization, aggregation, splitting, cluster migrations, copying data between different environments, filtering PI sensitive information. So these are the various other use cases for which we use MirrorMaker for. Moving on, now I'll talk about what are the different best practices which you should be following if you are setting up MirrorMaker cluster. So don't use different compression codecs on your source and destination cluster. So let's say if you are using gzip on the source cluster and LZ4 on the destination cluster. So what can happen is the message size can differ between your source and replication cluster. And it could hit the max message byte limits, which could break your replication pipeline. So you should always make sure that the compression codec is same across both your source and destination cluster. Next is don't set up MirrorMaker with the default offset as earliest. Because if you start up your MirrorMaker cluster and offset is set to earliest, lot of data will start getting consumed instantaneously from the primary cluster, and it can potentially impact the performance. So always set the MirrorMaker cluster with the offset set to latest. Make sure the number of tasks, like there is a property in MirrorMaker, it should always be greater than or equal to the total number of partitions which you are expecting the MirrorMaker setup to replicate. So this number of tasks should always be greater. You can derive how many MirrorMaker nodes you need for your cluster, which is equal to the total partitions in the source cluster divided by number of virtual codes in each worker. So this can give you the formula about like how many worker nodes you need in your MirrorMaker cluster. Few more, like you should run one MirrorMaker cluster setup per DC for active-active setup to work. These are the few configurations which you should be knowing about if you are facing any replication lag or to increase the throughput of your MirrorMaker cluster. So you should look at increasing fetch min bytes and batch size to reduce round trips. You should increase num streams if your consumption is too low. And this is very important. Make sure that your message max bytes is same across clusters. So we have run into an outage in production where the message size was set to 1 megabyte in the primary cluster, whereas it was set to 1 megabyte in the destination cluster. So it broke our replication pipeline because of a edge case. So make sure that message max bytes is set same across both your source and destination cluster. Now, and next I'll talk about what are the different challenges we have faced over the years in setting up the MirrorMaker. So earlier I talked about that there are two different ways in which you can set up topic replication. Basically, the DC one, basically where you want to keep the topic name same across your data centers. So for that, you can use identity replication policy, which is available in Kafka 3.x. It ensures that your topic name, so the default replication policy always adds a prefix of the data center, but using identity replication policy, you can ensure that topic name remains consistent across the clusters. Now, assume you have set up identity replication. How do you prevent infinite loop between your data centers? So for that, we have implemented a consumer identifier interceptor. So every time we produce a message, we add a header of farm origin, which basically tells where this message was originated from. So all of the applications which are running in Mumbai, they add their farm origin header as MH. So while replicating, we ensure that we check whether the destination farm header and the originator farm ID are equal or not. So based on that, we are able to provide infinite loop, which could potentially happen if your topic names are same. So we have named it as DC identified interceptor, which basically does the header checking before replicating. Another challenge could be task assignment skew across workers. So if you are on a Kafka version below 2.7.0, 2.8.0, make sure that you use eager rebalance instead of a cooperative incremental rebalance. Yeah, I guess that's it. Like, we'll come to the end. Yeah, we are open to questions now.
Hi, good session. I had just a couple of questions.
Yeah.
Yeah. So have you compared this with cluster linking because this offset translation and other operational challenges that you have with MirrorMaker, right? Where you have to set up a Kafka Connect and all those details. Those will be solved with cluster linking. So is cluster linking was compared with this and then a certain decision was made to use MirrorMaker? The second question on this is like if we are using MirrorMaker, do you have like one-to-many setup? Like one cluster can write into different clusters and does it also handle schema evolution and things like that? Yeah. The last one is how do you handle throughput? Like what's the blocker on the throughput? Like is it the number of partitions that the topic have? So these are three questions that I have.
I'll take that. Yeah, so I'll take it in the order, right, in which you post. I believe the first question is about, sorry, I didn't get that like fully. So you were talking about the offset translation, the challenges, right? Could you just like...
No, my question was because in MirrorMaker you have to use offset translation, you have to set up a different Kafka Connect clusters, right? And those things are resolved like in cluster linking things. So you don't have to set up those.
Cluster linking. So you're talking about the stretch clusters, right? The synchronous.
So cluster linking is provided by Confluent for
so,
replication.
So one thing, right, about PhonePe, right? So we are, all of our Kafka deployments are on, in our own like DCs, like data centers, right? Colos. Okay, so we are not on the, many of the clusters are not on cloud, right? And we are not using Confluent Cloud. We are actually using like OS's version of Kafka. So this is something that I should have mentioned. But anyways, like your question is still valid. So there are certain challenges with offset translation, but I believe like most of them have been solved in versions 3.5.0 and above. Like we are trying to like migrate to that, right? But of course it's with its own challenges with Kraft, right? Not working with JBots because we use JBot setup. So we are like testing this and we will of course move in like due time. So what has happened is like in 3.5.0, so there is a problem, right, with the offset translation logic in like older versions. So what happens is like it is going to be inaccurate in cases where the consumer group, right, on the source cluster is always lagging behind the source connector. So it's not able to do an exact translation, right? Even though, you can set it to sync the checkpoint as frequently as possible, right? So this is something that is known. It's a known problem. So what has happened is in 3.5.0, so there is a best effort translation logic, right? Even for the older like offsets. But again, like it's not going to work in all the cases. Okay, so there will be some sort of like broken like logic. So there is a follow-up like keep, right, to sort of like fix that. So of course, for the time being, like we don't have too many idempotent consumers. So where it becomes a problem is when you like your pipelines cannot deduplicate. But most of the times, luckily, we have some kind of identifier which we can use to like implement deduplication in our like Flink or like Spark streaming pipelines. So to speak. So this is the first question. I believe the second
to answer your third question, I remember your third question. So mostly the throughput, we see the number of partitions becomes the bottleneck. So if your source cluster is having, let's say, 100 partitions and you start seeing lag, so it's mostly the parallelism. So if you increase your number of partitions in the source cluster, so you will mostly see the lag getting cleared up. So the number of partitions is usually the bottleneck in the source cluster.
What are the other areas that we should be checking when there is a replication lag between the
number of cores is another. Like you should always make sure that the number of total cores in your MirrorMaker cluster should always be greater than the number of total partitions. so that each core at least gets one partition to replicate. So that's another parameter you should look at to reduce the replication lag if it ever comes up. Network usage is another, but usually we don't get bottlenecked on network.
Yeah,
Usually
that was my question. Like, if multiple producers are writing to a cluster at that moment, right? Will the network will also be a bottleneck in that part because during the replication lag, or do you like set up some sort of time in a day where this replication happens? Or is
No,
it
this
like
replication happens continuously because we can't expect a lot of delay on the other side because the other consumers in the other data center also needs to act on their data in almost real time. So as I said in the earlier slides, the replication lag is close to few milliseconds or up to 2 to 3 seconds. So the replication is happening like continuous. And since we have a dedicated link between both the data centers, so far we have not been hitting those network limits. So we are sorted there.
Yeah, I want to add one more point to this. I think like, yeah, if you are facing lag issues, I think like if I were in your position, I would probably look at the health metrics of the source and target clusters first. And the other thing is like try to keep the number of like partitions to a minimum. Like I think generally we have seen a pattern where like producers try to like increase the partitions too much. So it results in an over partition like topic, which poses problems. And the other thing you can look at is like tuning the batch sizes. So then you can get better, like compression ratio and like you can reduce the network bandwidth usage.
Yes. To answer your second question, we don't have a setup yet where from one Kafka cluster we are replicating to multiple Kafka clusters. So usually we follow a principle that between two Kafka clusters, there is a single MirrorMaker cluster which is taking care of. But across different Kafka clusters, like we have a single MirrorMaker cluster also, which is taking care of replicating across multiple Kafka clusters. But from one Kafka cluster, so far we have not been replicating to multiple destinations.
So you have to set up multiple Kafka Connect for replicating?
No, it comes embedded as part of, that's the mode that we run it on. So, I mean, like we use Kafka Connect for running Debezium and other things, but that's a separate cluster.
So single Kafka Connect can replicate across.
Yeah. So Kafka Connect comes up as part of this thing only, like MirrorMaker. So it is like co-located, right? So you don't need to, like connect it to an external, like Kafka Connect cluster.
Yes.
Thank you.
I think he was also.
There are some in the front
people
as
like
well.
waiting for a long time. Yes. Yeah. Please go ahead.
Yeah. Thanks for the great session. So my question is specific to the Kafka version. So in event of when you're upgrading your Kafka clusters, does your MirrorMaker work? I'm pretty sure you upgrade one cluster at a time. So during this upgrade, does your log messages or what are the messages that you're transferring, replicating it, is it compatible with the difference in the versions of the clusters?
I'll take this. So I think this is like a good use case for like putting like MirrorMaker to work in these kind of scenarios, right? Wherein you have like wherein you are doing a major version upgrade. Generally, it's a problem when you are doing a major version upgrade, like jumping from 2 to 3, or like maybe like now 3 to 4. I don't know. So then in that case, you can probably use MirrorMaker, right? And then see, generally it depends upon wire compatibility between like client and server. So even with major version jumps, generally we don't see like client and server like wire compatibility being broken. But of course, the cluster operations and other things change. Configurations become like deprecated, right? Semantics are changed. But as long as wire compatibility is there, it is something that we can work with by setting up MirrorMaker and then copying it. Otherwise, if it is so broken that we cannot fix it, then like we'll have to go with an approach wherein we'll have to like have some kind of like temporary cluster in the middle which will sort of help us migrate. So otherwise, you can also like think of backup, and restore kind of strategy, followed by replication with another buffer cluster. So there are many options there, or you can do like application side dual writes. So where you can control the integration with Kafka. So hope that answers your question.
Yeah, thank you.
There are some in the front.
All right, we have time for one more question.
Yeah.
Hey, hi. First of all, great session. I'm Vikas Tumar. I work at Myntra. So you talked about offset translation, right? Since you work in such a financial critical environment, that is PhonePe, how do you make sure that these offset translations don't cause inconsistency, especially in case of disasters?
Thing is like, so above and beyond, right? The offset translation logic, which is used, which is supported by MirrorMaker, will have to have, let's say, application side, like checkpoint. So wherein you can like do some kind of seeking to an older offset. right? And then like start reading from there, right? Just to be 100% sure. And then implement some kind of application side like filter. It could be based on, let's say, NTP synced timestamps, right? As an example, right? Which is also not like 100% foolproof, but it is something that you can actually work with. So in the absence of offset preservation, this is something that you can consider. So, but I do like share the same pain and agony with you when you say like, offset translation logic like needs a revisit. So I hope the community like will come and, come together and solve it later point in time. So
can the strategy lead to deduplication, duplication basically?
Yeah. So deduplication is something that you can implement in your application side by relying upon, let's say, consistent ID generation, like which can go into a header or something, right? Or maybe you can generate it using checksum. And then like, but you will have to like, let's say, use a state store. If you are on Flink, you can like, sort of like do this like out of the box. Or if you are like running other kind of streaming consumers, like maybe even, let's say, Kafka stream or like Spark streaming, you always have you can implement your own state store logic where you can store these like like store this information, like whether you have already processed, or you can rely upon incremental ID generation, so which will be like even more like simpler to work with.
Thank you for PhonePe for the presentation. Reminder to please rate in the app, and the next session will start in 10 minutes. Thank you.